want you to remember some properties of exponents for me real quick before we talk about properties of logarithms. Okay? If I have x squared times x to the fourth, what do I do with those exponents because I'm multiplying their bases? Add them, right? So I get x to the sixth, right? What do I have if I have x to the fifth over x squared? You subtract them, right? I'm dividing like bases, so I subtract the exponents. And what happens if I have x to the fourth raised to the fifth? If I have a power to a power, I multiply, right? If you can remember these properties of exponents, today you're going to be fine with properties of logarithms. How are logarithms and exponents related? How are they related? We wrote it down 2 times on one of our papers, and I told you how important that was. They're inverses, right? They are inverses of each other, which means they have similar things going on in their properties, okay? So, the first kind of thing that we're going to do today is we're going to expand logarithms. Expand. The problem for expanding might look something like this. Log base 2 of 3x. This is a super simple one. I'm starting off super simple with you, okay? And then we'll just get to regular simple in a little while. To expand it, what's happening with the 3 and the x? What are they doing to each other? They're multiplying. So what do you think I ought to do with them if I expand them? Add them. Log base 2 of 3 plus log base 2 of x. Done. What if it gets more difficult, though? Do we panic? No. You can panic a little bit. That's fine. But then we get back to work. Okay? Log base 4 of 2xy. Ooh, that's way more difficult. How many times should I have log written on this answer? 3. Why 3? There's 3 parts, right? So log base 4 of 2 plus log base 4 of x plus log base 4 of y. Done. Can I try to trick you? Yeah? Okay. Log base 5 of 3 over x. What would this look like if I expanded it? Log base 5 of 3. Oh, minus log base 5 of x, sorry. Very good. Why would I subtract here? Because I am dividing. Why did I subtract here? Because I was dividing, right? This is an x. Sorry. So I couldn't even trick you, right? Well, let me try again. Log base 6 of x squared. Something has to be times, right? Because it's raising to an exponent, and we know that if we're raising something to a power here, we timesed it. The difference is this exponent is what becomes the multiplier down in front of the logarithm. So yes, absolutely. You knew it had to be something to do with timesing, right? Okay? Dang it. I couldn't trick you that time. Right, let me try one more time. Okay. Log base 7 of the square root of x. That's a good guess. Log base 7 over x. Wouldn't it be easier if I rewrote this in exponential form? What is the square root of x written in exponential form? What power is it the same as if I take a square root? Close. 1/2. 1/2. So if this is the same as x to the 1/2, now can you tell me what the expanded form is? What do I do with the 1/2? Yep, put it in front of the log. Way to think through that. Very good. Can you do this one? How many times should I write log on this problem? Good guess. How many times did I write it up here? 3. So how many times am I going to write it down here? 5. 5. Okay. So how do you know it's 5? There's a term. 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 Okay. If I start writing it up here, I'm not going to have room, so I'm just going to start writing it right down here. Is you okay with that? All right. Log base 8 of 2. What's next? Plus does it have an exponent? What do I do with the exponent? Very good. Of x, right? Now what? Plus? Okay, we're in agreement. Log base 8 of 3. This is one way to write the answer. It depends. It's really, really personal choice here. Okay? I would write it the other way, but this is a perfectly fine example of how to write the answer for this problem. Can I show you the other way? Only just because it makes more sense in my mind. I understand this one though, and it's not wrong. Okay? I would write the answer like this. Log base 8 of 2 plus 2 log base 8 of x plus 5 log base 8 of y minus log base 8 of 3 plus log base 8 of z. Oops, 9. Do you see what I did? I put the whole denominator in parentheses because, see, I'm multiplying these two things, so I think I should have a plus between them, right? Which is fine as long as I have them in parentheses. Because think about what would happen if I distributed this negative to each term. Wouldn't it be this one? Yes, it would. Okay? Either one of these is a correct answer for this problem right here. Either one. Everybody okay with that? Okay. One more, and I'll try to trick you super, super bad. This is a 5. What is this the same as? Two x to the third raised to what power? 2x to the third raised to what power? 1/2, right? So how are we going to expand it? What happens to the 1/2? Okay, so 1/2 log of 5. Log base 5 of what? Of 2. And then what? 3. This is almost right. What's being raised to the 1/2 power? The whole thing. So the whole thing is being raised to the 1/2 power. That's kind of tricky, wasn't it? Was it hard? No. We just think about it step by step and it's fine, right? Okay. So there's two properties of logarithms that we're talking about today. We're talking about expanding our logarithms, and we're talking about condensing our logarithms. I don't think I need to hardly give you any examples of this, but I will, just to prove to you that I don't need to give you any examples of it. Condense it. When we condense it, we write log one time. So what are we doing compared to what we just did? It's going backwards. Okay? If I say log base 4 of 5 plus log base 4 of x plus 3 log base 4 of y, what should that equal in condensed form? Wait, how many times do I write log in condensed form? Once. Log base 4 of what? Five x y to the third. Done. Should I try to trick you? No, you're done with that today? Okay. I'll just give you regular problems. Is that all right? Okay. Oh, actually, I am going to try to trick you, just to be sure. Okay? What did I do to try to trick you? That's a 7, and that's a 7, and that's an 8. Can you condense logarithms that are of different bases? No. You can have a solution, but we're just going to put a frowny face because I don't want you to try to condense logs of different bases. We can still condense these two, right? We can get log base 7 of 2x to the fourth, but then we would still have 3 log base 8 of x because we can't put these two together. Okay? If we're condensing, all of the logs have to have the same base. Okay? All right, what about this one? I don't know what that's supposed to be. I think it's supposed to be an x. What is that if I condense it? Wait, do all the logs have the same base? What's the base? E, right? So we just have to write ln. It's natural, correct? So what do I get? No, I don't even have to write the e. 2x divided by What is this for? Y to the fourth. And then square root of z. Right? I could put z to the 1/2. That would be perfectly fine. But I see that you're remembering that raising to the 1/2 power is the same as square rooting, right? You okay with this? So, guys, this is one of those lessons that it's a little bit difficult for me because I want to be able to tell you why we're having to do this, but it's not time for that yet. Okay? Today I have to show you how. Next time we meet, I'll show you why. Is that fair? I'll show you why we have to know how to expand and condense, but today I just need to make sure we know how to do it. But I will show you why soon. Is that fair? Okay. Problems are on the board, 13 through 20 and 23 through 30. Any questions?